Good afternoon, everyone. Welcome to the session after lunch. My name is Arjun, and I'll be the chair for this session. So without any further ado, let me introduce the first speaker, Hendrik Mohrmann from CONTAG AG, and he'll be talking about a versatile toolbox for innovative mechatronic systems in industrial applications. Welcome.
Yes, thank you very much for the kind invitation. Welcome everybody to my contribution today. So you already said I'm talking about a versatile toolbox of our innovative mechatronic systems. First I would like to introduce our company. So we are actually a PCB producer here in Berlin. So we're here at home. We're a family business since '81, about 100 employees, and our main business is different to many others here. It's a PCB production. So we are from the old world. We're specialized in prototypes, small series, and we do that in express delivery for many clients. And we're active in many R&D projects as well. I'm going to come to that in the end. So what I would like to present today to you is, well, three-dimensional products from the PCB world. So among these, the rigid flex is pretty common and established in the industry, so I'm not going to talk about that too much. It's polyamide with typical FR4 boards. What I'm talking about and presenting here, and you'll also see that at our booth, are stretchable electronics on polyurethane and 3D MID. So I'm first going to talk about stretchable electronics. So this part you've seen lying around here, we can achieve on polyurethane with pure copper. So all of this, what I'm presenting here, is bulk copper. There's no ink jetting, no screen printing. We have a bulk copper foil that we etch. We can reach 30% stretchability with that. That's of course depending on the layout that you use here. We can use a high line space. I mean, we can even go to 50 microns. That depends on the PCB technology that we have, since we use the standard process that is in PCB integrated. We can produce multi-layers, so we have a rigid part, and there's no plug and no cable. We can embed different sensors. This is a DMS sensor embedded and connected with laser blind wires. And we can also integrate it. Here is an anisotropic conductive sheet integrated into screen printed silver inks. And the stuff that we're producing, that is assembled with standard solder, so you can treat it with normal assembly process without any glue or stuff. I'm going to come to that later as well. So first I would like to talk about the dielectric, like the materials that we're using. We're right now on thermoplastic polyurethane. I think a lot of people use it here, and you're all familiar with that. The softening range is quite low in respect to PCBs. So we're laminating this to a copper foil, and then we etch it. It is medical grade, of course, so you can develop wearables from that. Yes, and it is stretchable, so it doesn't pick up any of the lateral stress that goes into the product. So this is where we need to have some strategies to overcome this and protect our copper. So there's a product also presented here on the fair from Panasonic that's called Bayolex, and they go away from thermoplastic polyurethane, but they have an epoxy that is actually thermosetting. So with this, they reach a heat resistance of more than 300 degrees Celsius, and that solves some of our problems. So we're very excited to test this new innovative material as well. So the other part that we need to integrate, of course, that's the conductor. And here we always have the choice between copper and conductive inks. And I would like to advertise here that also copper offers some advantages over conductive inks, which are very much in favor here at this fair. So we have, of course, a higher conductivity. We have no hysteresis in stretching. So if you compare here these materials, I just put some up here, and excuse me if I'm not up to date, because there's a lot of development in the inks and it's difficult to keep track of those. But the main thing is resistivity of copper is much lower. And you have this diagram here. It's still from DuPont, now it's Celanese, but it still says the same. Resistance changes over strain, and it has a hysteresis. And here you see in comparison polyurethane, copper on polyurethane, and you have here a strain. And here the cycles to failure, where failure actually means a change in resistance. And you can go to 10,000 cycles here when you have more than 10% stretch. So that is quite okay. Still, it's a lower stretchability. So I'm not advertising copper over conductive ink.